Hello and good morning. My name is Ferhan Mazher, and right now I am with the 11th Cambridge class, and the subjects we are studying is Physics 5054. And today we have set our hearts to solve May June 2013 1 paper. It's MCQ paper, and it belongs from the Zone 1. So let's start this paper, and hopefully you will be able to uh, understand it. So let's start. So the paper we are doing is May June 2013 1 paper. It's MCQ paper. The time duration is 1 hour. There will be 40 MCQs. You have to attempt all of them. Okay. So on your screen, the first question is showing, and he says forces of 3 Newton and 4 Newton act as shown in the diagram. Which diagram shows the resultant R of these two forces? So let me show you the marking. Let me show you the whole situation. The whole, I mean all the options available. So these are the so these are the options which are showing on your screen, and let's see what happens. If you have the two vectors like this and you want to add them, so the methodology is very simple. Let me show you. I have shown here. So you see, if you want to add two vectors, the methodology is very simple. You put those two vectors in such a way that their tails are joined together. And the method I'm going to use to add these vectors is the parallelogram law. So what I will do, I will put these two vectors in such a way that their tails are joined, and then I will suppose that they are the adjacent sides of a parallelogram. So you can see the red, both 3 centimeter vector and the 4 centimeter vector. I put them, their tails are joined. Then I will complete the parallelogram, and you can see with the blue lines, I have completed the parallelogram. Then where the tails are joined, I will join that vertex of the parallelogram with the opposite vertex of the parallelogram. And by doing so, I will get a line, which you can say this line I am talking about. And this line represents the resultant. The direction of the resultant will be where the tails are joined from that point to the opposite corner. That will be the direction. So this is the resultant. So the resultant we should get the resultant like this. This is how we get the resultant vector of these two vectors by the parallelogram law. So let's check what are the options, and I think A is the right option. I think A is the right option. Let me check the answer also. I have already written the answer, so to save the time, yep, A is the right answer. So A is the right answer. The rest of the answers are wrong. Okay, so let's move to the next question. And the next question is on your screen. He says, they say a micrometer used to measure the diameter of a uniform wire. What is done to obtain an accurate answer? Find the reading and add or subtract the zero error. Yes, this is the answer. This, I think, is the right answer, but let's read the other things also. Make the micrometer horizontal. That's not true. Subtract the fixed scale reading from the rotating scale reading. We add them up. So C is also not right. Subtract the rotating scale reading from the fixed scale reading. That's wrong. So A is the right answer, and marking scheme also says A is the right answer. So the next question on your screen is question number 3. The speed time graph for a falling skydiver is shown below. As he falls, the skydiver spreads his arms and legs and then opens his parachute. Which part of the graph shows the skydiver falling with the terminal velocity? So it's a speed time graph. And when the skydiver will be falling with the constant velocity, with the terminal velocity, the velocity will be constant and the speed time graph should become flat. It should become horizontal. So I think D is the right answer. So I think D is the right answer. Question number 3. A particle P is moving in a horizontal circuit about O. P moves at constant speed. Which statement is true? A force of constant size acts on the P in the direction of the motion. That is wrong. A force of constant size acts on the P towards O. Yeah, that is the centripetal force. So that should be the answer. The force on P varies in size as it moves around the circle. Now, there is no resultant force acting on the P. That is also wrong. So there is a force which is acting on the object P when it's moving in a circle, and the direction of that force is always towards the center of the circle in which that body is moving. So the force of constant size acts on P towards O. That is the right answer. Question number 4, B is the answer. So now we have the question number 5 on your screen. A body slides down a frictionless slope as shown. Yeah. A body slides down a frictionless slope as shown. As the body presses on the surface pushes back on the body. The force of the surface on the body is sometimes called the reaction force. In which direction does the reaction force act? So the reaction force will be perpendicular to the surface. It will be perpendicular to the surface. The reaction force should be perpendicular to the surface. So I think C is the right answer. I think C is the right answer. Question number 5. Okay. So the next question we have is question number 6. A paper is sold in packets labeled 80 gram per meter square. This means that a sheet of paper of area 10,000 centimeters square has a mass of 80 gram. The thickness of each sheet is 0.11 millimeter. What is the density of the paper? You know, I know the area of a single sheet of paper, that is 10,000 centimeters square. I know the thickness of the one sheet of the paper, that is 0.11 millimeter. So convert this into centimeter. So if you want to convert 0.11 millimeter into centimeter, you have to divide it with 100. Sorry, with 10, because there are in 1 centimeter there are 10 millimeters. So divided with 10, you get the centimeters. So multiply the area with the thickness, you will get the volume. Once you have the volume, we know the mass of one paper, that is 80 gram, divided with the volume of the one paper, and you will be able to get the density of the paper. I've done this on a paper. Let me show you my work. So on your screen, it is showing that the volume of one sheet of paper is equals to area multiplied thickness. Area is 10,000 centimeters square, multiply 0.11 divided by 10. I convert the millimeter into centimeter. So I will have the volume 110 centimeter cube. Mass of one sheet of paper is 80 gram. So the density will be equals to mass divided by volume, and it will be 80 divided by 110. So it will be 0.73 grams per centimeter cube. 0.73 gram per centimeter cube. So let's check the options available. The options we have 0.73. So C is the choice. Which chair is least stable if the child moves? The least stable will be that chair whose whose center of mass is highest and base area is smallest. So very easily you can see the base area smallest and the center of mass highest is in A. So question number 7, A is the choice. Okay. Now you see a brick of weight 80 Newton stands upright on the ground as shown. So the weight is 80 Newton. What is the pressure it exerts on the ground? The pressure formula is very simple. Weight divided by the contact area. Weight divided by the contact area. So weight is 80 Newton. The contact area will be 10 centimeter multiplied 5 centimeter. So you will be able to find out the pressure very easily. Let me show you my work. I've done this and let me show you my work. So pressure is equals to weight divided by area. So it will be 80 Newton divided by 50 centimeter square. So it will be something like 1.6 Newton per centimeter square. 1.6 Newton per centimeter square. Weight divided by contact area. So I think question number 8, D is the right choice. An airtight container holds a fixed mass of gas. Its pressure and volume are measured on 4 occasions when the temperature is 20 degrees centigrade. The results are shown in the table. 3 sets of readings are correct. Which set of reading is not correct? An airtight container holds a fixed mass of gas. Its pressure and volume are measured on 4 occasions when the temperature is at 20 degrees centigrade. So you see the temperature will not be changing. So if then the temperature is not changing for the gas, we have the formula P1 V1 equals to P2 V2 equals to P3 V3 equals to P3 P4 V4. The product of the pressure and the volume should remain constant. So what I will do in each option, I will multiply the value of the pressure with the value of the volume. And I will check what's the answer. So their answers should be same. In all of them, they should be same. So in one of them, they will be not, they will get a different answer. So we have to check which one is not correct. That one will be one of them, which will have not the same product like the rest of them. That one will be the different. I've done this on a paper. Let me show you. And here we go. So P multiply V should be constant. So I multiply the P1 V1, multiply P2 V2, multiply P3 with V3, I multiply P4 with V4. So I get the answers. You can see the last three. For the last 3 options, the product remained 4800. And that is that means they are obeying the law. The product of the pressure and the volume when the temperature is constant for a gas inside a cylinder, the product should remain same, constant. But the first option, the product is 4320. So it means the first one is not the right answer. So we were supposed to choose which was not the right answer. So A is right. A is the one whose product is not same. Okay. So A is the choice. Energy is released in some power stations and in the sun by either nuclear fission or nuclear fusion. Which type of nuclear reaction applies in each case? In the power stations, we are doing fission. And on the sun, the process of fusion is taking place. So clearly, B is the answer. Question number 10 is the easy part. It's very easy. B is the answer. The diagram shows a girl lifting a box of weight 50 Newton. Now from a low shelf to a high shelf. How much work is done on the box? You know the work done, I can find out the change in the work done is equals to the change in the gravitational potential energy. So she moved this load from a height of 0.6 meter to a height of 1.8 meter. So that's first of all, I need to find out how much is the difference of height between these high shelf and low shelf. So that will be very easy, 1.8 meter minus 0.6 meter. And I think it will be 1.2 meter. So the height will be 1.2 meter. Work done is equals to the gain in the potential energy. So that will be mgh, or you can say weight multiply the vertical height. Simply put the values and you will get the answer. So I've done this on a paper. Let me show you my work. And here you can see the height is, it will be the height which the box moved, that will be 1.8 minus 0.6. It will be 1.2 meter. So work done is equals to the potential energy, that will be mgh, or you can say weight multiply the vertical height. So it will be 50 Newton multiply 1.2 meter, and the final answer will be 60 joules. So B looks the right answer, sir. Question number 11, B is the right answer. The diagram shows the energy transfer through a machine. The machine is 50% efficient. Which equation is, you see, when a machine is 50% efficient, it means that if you put 100 energy in it, the input energy is 100, the 50 joule energy will be wasted, and the 50 joule energy will be useful. So the wasted energy and the useful output energy, they both should be equal to each other. So I think the D is the right answer. The wasted energy and the useful energy, they will be equal to each other. The output useful energy. 50% efficient means that 50% of the energy will be wasted and 50% of the energy will be useful, the output useful. So it means that the wasted energy and the useful output energy, they both will be equal to each other. Question number 12, D is the right choice. The glass beaker contains water. When the center of the base of the beaker is heated, a convection current is set up. So here you are heating, and you can see here hot water is going up, and from the side the cold water is sinking down. Which statement explains this? The evaporation of water causes water molecules to rise to the surface. No. The expansion of the water molecules causes them to rise to the surface. That is right. But you know, the molecules, they don't expand. So he said the expansion of the water molecules. The expansion of the water molecules never takes place. The water above the heat source rises because it's become less dense. That is the perfect statement. And the last one is the water at the sides sinks because it becomes less dense. That's wrong. So I think D is the best option, sir. The D is the best option. Sorry, I said D. C actually, it's C. C is the right option for question number 30. Two identical metal plates are painted, one matte dull white and other matte black. These are placed at equal distances from a radiant heater as shown. The heater is turned on for 5 minutes. Which metal plate absorbs more energy and which metal plates emit more energy in this time? You see here we have a heater, and here we have and it's a radiant heater, is giving out infrared radiation. So here I have a white colored metal plate, here I have black colored metal plate. The heater was switched on for 5 minutes and then it was turned off. The question to us is which one will be absorbing more infrared radiation and which one will be emitting more infrared radiation. In both these works, this matte black metal plate will be the best. When it's absorbing heat, it will be the best absorber, and when it's emitting radiation, it will be the best. It will be best to emit the heat also. So for both work, black. So I think question number 14A is the right choice. I'm checking with the marking scheme also. Okay. So you see, it's a rule. It's a rule for I have made this rule for us and for our students also. Whenever we solve a question, we always check its answer from the marking scheme. So I am checking with the marking scheme. It says using an electric kettle, 200 grams of water at 100 degrees centigrade is converted into steam at 100 degrees centigrade in 300 seconds. The specific latent heat of steam is 2250 joules per gram. What is the average electric power used? You know, the power will be equal to energy divided by time. The formula for the power should be energy divided by time. And energy here is equals to ml divided by time. Energy will be ml and divided by time will give you the power. M means the mass, L means the latent heat. And you can see the specific latent heat is given and the unit of the specific latent heat is joules per gram. So the mass should also be taken in grams. The temperature is 100 and this whole thing happened in 300 seconds. So you see, what is the average electric power used? That will be 200 m multiply L divided by time. 200 multiply 2250 divided by 300 seconds. So this will give you the power. So I think B is the right answer. Question number 15, B is the right answer, sir. Heat is M multiply L. M stands for mass, L stands for the specific latent heat, and T stands for the time. Heat will be equal to M multiply L divided by T. Okay. When a gas in a container of fixed volume is heated, the pressure of the gas increases. So fixed volume. So this is very important. Fixed volume. The volume is not changing. So the pressure and the temperature, they will be directly proportional to each other. When you will increase the temperature, the pressure will increase. If you decrease the temperature, the pressure will decrease. When a gas in a container of fixed volume is heated, the pressure of the gas increases. Which statement explains this? The molecules expand and get heavier, so they hit each other harder. You see this molecules expand thing, that is totally wrong. The molecules do not expand. The molecules have less room to move, so they collide with each other more frequently. No, the volume is fixed. It means the volume is not decreasing. So B cannot be the answer. The molecules hit the walls harder and less frequent. Yes, they hit the walls harder, but more frequent, not less frequently. The molecules move faster, so they collide with the walls more frequently. This is the answer. The molecules would have started moving faster. Their kinetic energy has increased because the temperature has increased. So the molecules move faster, so they collide with the walls more frequently. So D is the right. Question number 16, D is the right answer. And then we have question number 17. A ripple tank is used to show wave behavior. The dipper vibrates up and down at a constant frequency. What happens? What happens to the frequency and to the speed of wave as it reaches the glass block? So you see here the water is deep, here the water is shallow, here the water is again deep. So when the water waves will reach in the deep waters, their frequency will be the frequency of the vibrator, but their wavelength will be larger, their speed will be higher. When the water waves will reach in the water where the depth is less, when the water is shallow, the wavelength will decrease and their speed will also decrease. And the frequency remains unchanged. It will be the frequency of the vibrator. And when they again reach in the waters where the depth is higher, larger, so water is deep, again the wavelength will increase, the speed will increase, but the frequency still will be the same as that of the vibrator. So what happens to the frequency and the speed of the wave as it reaches the glass block? The frequency should remain unchanged. It should remain the same. And the speed that will decrease. In the shallow water, the speed of the wave decreases. So I think C is the right choice. Question number 17, C is the right choice. A wave has a frequency of 10 kilohertz. It means 10,000 hertz. Which pair of values of its speed and wavelength is possible? Okay. So what I will do, I have speed here and I have the wavelength here, V and lambda. So for all the four options, I will calculate the frequency. And let's see which one gives the frequency equals to 10,000 hertz. So I've done this on a paper. Let me show this question number 18. So let me show you. Yeah. Question number 18. So here we come. F is equal to 10,000 hertz. So we will check for all the options that which option the frequency will be equal to 10,000 hertz. You know, V is equal to F lambda. If I make the F alone, I make F the subject of the formula. So F will be equals to V divided by lambda. Lambda stands for the wavelength, V stands for the speed, F stands for the frequency. So F1 will be equals to V1 by lambda 1, 330 divided by 0.33 equals to 1000 hertz. 330 divided by 33 equals to 10 hertz. And 3 expo 8 divided by 30, it will be 1 expo 7 hertz. 3 expo 8 divided by 3 expo 4 equals to, and it will be 10,000 hertz. So D is the right choice. 10,000 hertz, D is the right choice. So 10,000 hertz, D is the right choice. D is the right choice. Because these velocity and the wavelength value gives a frequency of 10,000 hertz. So D is the choice. I think you have understood. So which characteristic describes an image formed by a vertical plane mirror? In the vertical plane mirror, the image formed is virtual. It is upright. Its size is same as that of the object. Its distance from the mirror is equal to the distance of the object from the mirror. Real and inverted, no. Virtual and not inverted, that's wrong. Oh yeah, virtual and not inverted, that can be the answer. Not inverted means upright, straight. Okay. Real and larger, that's wrong. Virtual and smaller than the object, that is wrong. So the best option is virtual and not inverted. The image formed in the mirror, it's virtual, it's upright, or in other words, you can say it's erect. And the third word which he is using is not inverted. So B is the choice. A ray of light meets the face of a glass block at an angle of 30 degrees centigrade. As shown, the refractive index of the glass is 1.5. What is the angle of refraction R? Angle of refraction R inside the glass block. So this is not the angle of incidence. Remember, angle of incidence is this one. So I can find this angle of incidence by 90 minus 30. So the angle of incidence will be 60. Angle of refraction is question. And the refractive index is given, that is 1.5. The formula for the refractive index is very famous. N is equals to sine I divided by sine R. You know, in this formula, we always put that angle upstairs in the numerator, which is in the rare medium. So the angle of incidence, because it is in the air, that should be upstairs. So I will have sine of 60 divided by sine of R equals to 1.5. I will cross multiply and I will solve it for the R. I want to find out the value. I've done this on a paper. Let me show you my work. So So the angle of incidence will be 90 minus, the angle of incidence will be 90 minus 30, that will be 60, and n value is 1.5. So you know the formula according to Snell's law, sine I divided by sine R. So we will have sine 60 divided by sine R equals to 1.5. So make the sine R subject. So it will be sine 60 divided by 1.5. So sine 60 divided by 1.5, do this on the calculator, it will be 0.577. So R will be equals to sine inverse 0.577, and the answer will be 35.26. The answer will be 35.26. 35.26. So 35.26. So I can find out this answer. And let me show you 35. 35 something is the answer. Yeah. So you can see question number 20. The answer is C. Okay. So now you can see I have this question, and the question is on your screen. So it becomes too large. Okay. The diagram shows a thin converging lens of focal length f. Where must an object be placed to produce a real image in position shown? So if you want to draw this image, you know the focal lengths are already marked there. The principal focuses are marked. So let me show you my work. I've done this on a paper. So let's see. So you see the method. This is that diagram. So join the top of the image with the optical center, and this ray will go undeviated. So this red light, ray number 1, I have drawn. Starting from the head of the image, passes through the optical center, and it's undeviated, it goes straight. This red line I have drawn. Then I will use that green ray, ray number 2, start it from the head of the image and pass it through the F, the principal focus, on the same side. So when it will touch the lens, from there it will become parallel to the principal axis. The green light, the green ray I'm talking about. So what I have done, I have started from the head, pass it through the optical, through the principal focus on the same side. And when it comes into the lens, from there it becomes parallel to the principal axis. So this green ray, ray number 2, I hope you have understood this. Where these red and green, these rays, they will intersect each other. Where they intersect each other, there the object is placed. So object will be placed at the position A. So this is one question in which you have to actually draw on the paper, on that diagram which is shown to you. So let's check A is the right answer. So I think A is the right answer. So I think question number this. So for question number 21, A is the right option, sir. So now we have the next question, and that question is on your screen. And let me show you. Which wave property has the same value for all X-rays traveling in the air? All the X-rays which are traveling in the air, they will have, because they are part of the electromagnetic spectrum. So they all will have the same speed. All electromagnetic waves traveling in the air, they have the same speed. So I think C is the choice. Question number 22, C is the choice. Which range is the approximate range of audible frequencies for a human? You know, the audible frequency range for a human is from 20 hertz to 20,000 hertz. From 20 hertz to 20,000 hertz. So I think C is the right option. 20 hertz to 20,000 hertz. Question number 23, C is the right answer. Which row correctly compares the speed of sound in air, liquid, and gas? You know, the speed of the sound in solids will be the fastest, and then in the liquid, and then in the air. The behavior of the sound is different from the behavior of the light. Remember this thing. The behavior of the speed of the light, the behavior of the speed of light is different, totally opposite to whatever is the behavior of the sound. So the sound will be traveling fastest in the solids, and then in the liquids, and the slowest in the air. But this is not the case with the air. The air travels in a different, the air will be traveling in a different way, you know. So, so I think solid, liquid, and air. So this is the choice. Question number 24, D is the right. D is the right answer. Okay. A guitar string is made to vibrate. What makes the pitch of the notes rise? The pitch depends upon the frequency. So if you want to rise the pitch, you will have to increase the frequency. So what makes the pitch of the note rise? A decrease in the amplitude, it does not have relation with the amplitude. The decrease in the frequency of the vibration, that is wrong. It has relation with the frequency, but to make the pitch high, to rise, the vibration, the frequency of the vibration, that should increase. An increase in the amplitude of vibration, that's wrong. An increase in the frequency of the vibration. So D is the right answer. Question number 25. D is the right answer. Okay, so let's reduce the size so you can see the whole thing. Okay. A teacher sticks a magnet to the top surface of a matchbox cover. It's a matchbox cover. So on top of it, you have put a magnet. The bottom surface is placed in a small tray of iron paper clips. If the matchbox cover is lifted up, a large number of paper clips are held on the bottom surface. Sheets of metal are placed inside the matchbox cover between the magnet and the paper clip. When sheet X is placed inside, the paper clips stay attached. When the sheet Y is placed inside, all the paper clips fall off. So if the paper clips fall off, it means the metal sheet you enter is a magnetic material. So the Y is a magnetic material, it might be iron. And when you place sheet X and nothing happened to the paper clip, they still remain attached. It means that that thing is a non-magnetic material. That might be copper, that might be a stick of wood. So let's check what's the answers. So Y is supposed to be something which is, he says that sheet X is supposed to be non-magnetic, and the sheet Y is supposed to be magnetic material. So I think B is the right answer. And question number 26, B is the right answer. The sheet Y should be a magnetic material, which could be iron, and the sheet X should be a non-magnetic material like a copper. Okay. So now we have question number 27 on your screen. The diagram shows a small compass close to a strong bar magnet. Which diagram shows the correct compass direction? So the compass needle always points where the magnetic lines are going. So for example, in A, it's wrong. The magnetic lines here are going into the south. So magnetic compass direction is wrong. B is also wrong. C is a perfect answer. Here in this region, in this place, on this location, the magnetic lines are going into the south pole. So the C, the magnetic compass should be aligned with those lines. So C is the right answer. B is also wrong because here the magnetic lines are going into the magnet. So it should have be aligned like this. So C is the right answer. Question number 27, I think C is the right answer. Question number 28, a positively charged rod is held close to but not touching an insulated metal sphere. Which diagram shows the charges that are induced on that sphere? So it's a metallic sphere and you have brought a positively charged rod near it. So what will happen? The end of the sphere which is near to this positively charged rod, the electrons will be attracted there. So that end, I mean this left end of the metal sphere, it will have a negative charge, and the right end of the metallic sphere, it will have positive charge. The amount of the negative charge and the amount of the positive charge, they both will be equal to each other. So D looks the right answer. Question number 28, I think D is the right answer. The next question on your screen is question number 29. So question number 29 is showing on your screen. A lightning flash carries 40 coulomb of charge and lasts for 5 milliseconds. 5 milliseconds. What is the average current in the flash? So the charge is given, the time is given, and they want you to find out the current in it. So I is equals to Q divided by T. I equals to Q divided by T. So simply put in that formula and you will get the answer. Let me show you my work. So here you go. You see, Q is given 40 coulomb, the time is 5 milliseconds. 5 into 10 is power minus 3 seconds. I is equals to Q divided by T equals to 40 divided by 5 expo minus 3. So 40 divided by 5 will be 8 and to 10 is 3 ampere. So it will be 8,000 ampere. So you see the only problem in this question was, it was very easy, I is equal to 2 by T. The only problem is that the time is given in milliseconds. So if you convert it into second, then there is no problem. So 8,000 ampere. So you see here we have that option, and D is the right choice. So next question. Which of the following is equivalent to 1 volt? And you know the 1 volt is equal to the, the definition of the voltage is the energy divided by charge, work done divided by charge. So the unit will be joules per coulomb. Work done in joules and the charge in coulomb. So 1 volt is equal to 1 joule per coulomb. So I think this is the right. Question number 30, B is the right choice. The electrical resistance of a metal wire varies with the temperature as shown. The resistance of the wire at 0 degrees centigrade is 1 ohm, and at 100 degrees centigrade it is 1.40 ohm. What is the resistance of the wire at 200 degrees centigrade? It's very easy. Let me show you my work. I've done this on a paper, so you can understand it. Real quick, we are do this. So the formula is R200 minus R naught divided by R100 minus R naught equals to theta by 100. So R2 minus 1 divided by 1.4 minus 1 equals to 200 divided by 1. So it will be R200 minus 1 equals to 2 into 0.4, and R200 will be equal to 0.8 plus 1. 1 will go on the other side, will add. So it will be 1.8 ohm. So the resistance should be 1.8 ohm. I hope you have understood this. This is a famous formula. So A is the option. A is the right option. So a cell is connected in series with an ammeter and a lamp. The reading on the ammeter is 1 ampere. So when there is only one lamp connected in with this battery, the current coming from the battery is 1 ampere. In which circuit using the identical lamps, ammeters and cells is the reading on the ammeter 2 ampere? If you are using the same battery, how this is possible? Or if you are using double battery, how this is possible? That the 2 ampere current starts coming. So one way is if you keep one lamp and you make the batteries double, then the current coming from the battery will be 2 ampere. You keep the one lamp in the circuit, and you make two batteries. And those two batteries are connected in series with each other, then their voltage will add up. So you see, then the current coming from the battery for one lamp will be 2 ampere. But if you use two cells connected in series and you use two lamps, then again the current will be just 1 ampere. Another very good method is if you use a single cell, but the resistance of the whole circuit should become half. And how is that possible? That is only possible if I connect two cells in series with each other and I connect the two lamps in series in parallel with each other. Sorry, that is possible if you use a cell and parallel to that cell you connect two lamps parallel to each other also and parallel to the battery. And then what will happen? Their resistance will be half of the resistance of a single lamp. Then the current will become again one. The current will become double. You see, try to understand. Here D is the option. Why I'm taking D as the option? The reason is very simple. You see, the reason is that I want the current to be doubled. So where the current will become double, whatever was the situation in here, the current can be double only if the resistance becomes half and the cell is same. If the resistance of the whole circuit becomes half, the current coming from the battery will become double. So that happened in D choice. Okay, so let's move to the next part. So D, I think this was question number 32. 32, D is the choice. The diagram represents a part of a household circuit containing an electric kettle. Okay. The diagram represents part of a household circuit containing an electric kettle, metal case, and element, and then we have three wires. The wire which is connected with the metal case, Y wire, that should be the earth or the ground wire. The X will be the neutral wire. The W will be the live wire. How I know that is live wire? Because we have a switch in W. So the W should be live, X should be neutral, and the Y should be earth wire. So B is the right choice. Question number 33, B is the right choice. Okay. So a wire hangs between the poles of a magnet when there is a current in the wire. In which direction does the wire move? So you will apply the left hand rule. You take your left hand, stretch your fingers in such a way that they are perpendicular to each other, you know. So the thumb, the index finger and the middle finger, they are mutually perpendicular to each other. So you can see that. So FMC. So this will be in the direction of the current FMC. So magnetic field, this forefinger is magnetic field. Sorry, forefinger, index finger. So this is in the direction of the magnetic field. The current is going downward. My thumb is pointing towards me. So it means that the current will be in the direction of the force of, it will experience a force that will be in the direction of A. Question number 34, A is the choice. With the help of the Fleming's left hand rule, I am able to tell the direction of the force exerted on a straight conductor by a magnet. A straight conductor carrying current and experience a force acted upon it by the magnet. The diagram shows a simple DC motor. Which label part is the commutator? You know, this part, this ring, this is called the split ring commutator. So D is the choice. Question number 35, D is the right choice. Yeah. Next question. Two leads emerging from a box are connected to a sensitive ammeter. When the bar magnet moves towards the open end of the box, the needle of the ammeter deflects to the right. When the bar magnet stops, the needle returns to zero. It means when you are moving the bar magnet, the current is induced and the ammeter shows that reading. And when you stop moving the magnet, obviously no EMF will be induced and the ammeter will show zero reading. What is in the box? I think a coil. I think a coil. So A is the choice. Question number 37 is on your screen. He says, what is used in cathode ray oscilloscope to cause vertical movement of the trace? We have the Y plates. We have Y plates, and between those Y plates, the electron beam passes. And if the upper plate becomes positive, the lower plate is negative, the electron beam will be attracted upward. If the lower plate becomes positive, the upper plate becomes negative, then the electron beam will be reflected downward. You see, we use an electric field. We use vertical electric field to deflect the electrons. So question number 37, C is the right choice. So question number 38. Which component stores energy in a time delay circuit? Remember this word, time delay circuit. For the time delay circuit, we always use capacitors. And so A is the choice. I by mistake highlighted two things, but A is the choice. Question number 38, A is the choice. Capacitor is used to store the charge, and then it is used to store the electric energy, basically. So it is also used for delay, time delay. It says a school keeps radioactive sources for use in radioactive activity experiments in the laboratory. The background radiation is measured at the start of an experiment. Which statement is correct? The background radiation is caused by the school's radioactive sources in the laboratory. That's wrong. I don't think the sources of the radiation should be very kept safe in lead boxes. The background radiation is present when there are no radioactive sources in the laboratory. That is true. The background radiation is a radiation that is not detected in the radioactivity experiment. No, it is detected. The background radiation is the same in laboratories in different countries. That is wrong. It could be different in different countries. So I think the background radiation is present when there is no radioactive source in the laboratory. That is true. B looks the best options. Question number 39, B is the right option. Which nucleides have the same number of neutrons in the nucleus? So, for example, in option A, we have boron, and what you do, you subtract the nucleon number from the nucleon number, subtract the proton number. 12 minus 5, it will be 7. 6 minus 12 minus 6 will be 6. So the number is not same. So 1 minus 1, 0, the neutron number is 0. 2 minus 1, the neutron number 1, so that's not same. 12 minus 6, it will be 6 neutrons. 13 minus 7, it will be 6 neutrons. So C is the choice. He was asking us, where are the neutrons? Same thing. So if you have not understood, I have done this on paper also. Let me show you my work. And here you see. So I have only written here the correct ones, the carbon 12 and 6, neutron 13, 7. So find the neutron number in both of them. That will be the nucleon number minus the number of protons. And you see the answer you will get, that will be the neutron number. So 6, 6, so this is the choice. And let me show you what are the choice, exact choices. The exact choice is C. So question number 40, the C is the choice. So by this question, and now we have reached, and let me, okay. So my dear students, today we have solved May, June 2013 Physics 5054-11 paper. It's an MCQ paper, and we have solved this MCQ paper belongs from the variant 1 or zone 1. So hopefully this video is helping you, and if this video is helping you, and this video is helping you, and it has helped to improve your concepts of physics, kindly like this video and also subscribe to my channel, and also recommend these videos to your friends, your class fellows. Especially we are making these videos for those people because of the COVID-19, you cannot go out. So by sitting at your home, you will be able to solve the papers, and you will get the concept also. So hopefully these are helpful to you. So I think, thank you very much for today, and have a good day, and God bless you all. Thank you. Bye.